Thank you very much, Ding, for your great support and enthusiasm. Now, I've already discussed with you our team, our vision, our alliances, and that factor that sets us apart. We are very fast. I said that slowly, because I don't often do things slowly, because the rest of the time we're doing things fast. In fact, we're so fast that so far we have met all of our aggressive milestones. But I learned a lot of this from my predecessors, from my former employers. When I joined Jaguar, it was still part of a slow and struggling British car industry. But in 1984, Jaguar privatised, and under the leadership of the charismatic John Egan, we turned things round. The brand began to prosper, rapidly bringing out new products and returning to the winner's circle at Le Mans. And after Jaguar, I joined the legendary Lotus marque, and it's there that I learned principles of purity, of lightweight design, speed and efficiency. And then I moved to Tesla Motors. Tesla and Elon Musk have created something incredible, and we should all applaud them for it. The first mass-market electric vehicle, a great driving experience, a fiercely loyal customer base. They've created a growing, viable market for electric vehicles where none existed before, and they brought start-up thinking to the automotive industry. Now, Tesla was founded in 2003, and 5 years later, they produced a limited production Roadster based on the Lotus Elise platform. 7 years after founding, they began work on their first volume production factory and had 600 employees. And then after 9 years, they delivered their first mass-market production vehicle. Tesla moves at breakneck speed compared to the rest of the industry. But let me tell you about an update of where we are today. Faraday Future was founded just 18 months ago, and in that short year and a half, we already have a staggering 750 employees globally. And as I mentioned earlier, we'll be breaking ground on our 3 million square foot factory in just a few weeks. Yes, just a few weeks' time. And we will deliver our first production vehicle in only a couple of years' time. So all of this in just 18 months now, I call that very fast. Well, now, every venture is going to learn from its pioneering predecessors, and we're no exception. We're not only moving fast as a company, but we've also rethought all our processes and systems to be quicker and more efficient. Our design engineering processes are all digital, which gives us the ability to rapidly iterate new solutions and approaches, to make changes on the fly, and to use things like virtual reality to see our ideas come to life in just a few days, rather than waiting months. We can test parts in virtual worlds before we have any physical components to test. We can optimize, we can improve everything as early as possible. Yet, whilst we pride ourselves with this speed and agility, top quality is absolute priority for us. Our vehicles will only be available when we know we can build them with extraordinary high quality, products with great capabilities, great reliability, high performance, and features that truly respond to the user's needs. But what gives us the confidence to be able to make these claims, to be sure that we can rapidly get there whilst upholding the highest standards of quality? Well, one thing we have is that we've created a new and more advanced platform. We've called it the Variable Platform Architecture, or VPA for short. The car enthusiasts amongst you know there are lots of car companies out there who claim modular platforms. We've optimized this concept and tailored it for electric vehicles. With VPA, we can dramatically compress our time to market and reduce our costs. All of our vehicles will use VPA for this approach. And to give you a better sense of what VPA is capable of, we've prepared a short video, and I'd like you all to watch this now.
To achieve a diverse range of smart, fully connected electric vehicles, Faraday Future engineers have developed a new, innovative variable platform architecture. We started from the ground up with a new battery structure that's arranged into what we call strings. Adding or removing these strings both changes overall battery capacity and allows us to develop new wheelbases. Other than crumple zones, which are optimized in each specific configuration for safety, the front and rear sections remain the same. The FF platform also incorporates various motor configurations, ranging from 1 to 3, or with special modifications, 4 motor layouts. We are able to alter vehicle characteristics, including 2 or all-wheel drive systems, extended range options, and various power outputs, all using the same platform architecture. By fitting our vehicles with the latest in internet connectivity, we'll maximize the capabilities and experience of our state-of-the-art user interface. Plus, they come pre-equipped for increasing levels of autonomous driving and improved safety. This intelligent, modular approach, built on a flexible battery layout and multiple powertrain configurations, means we have the potential to deliver an extremely diverse range of vehicles to market, faster and more efficiently than previously thought possible.
So, as you've just seen in that video, VPA combines we combine adaptability with stability and safety, a best-of-all-worlds solution. With VPA, we can add or subtract strings of batteries. Based on those power cells, we can create different models that have our desired range without having to redesign the entire structure. And this is really important in terms of time, cost, efficiency. And one of the unique things about our VPA is that our battery configurations works in a way like a modern set of Christmas tree lights. If one goes out, the rest continue to function. It makes it much easier and much more cost-effective to replace and swap out parts. And with the battery pack in such a low central location, we can provide even greater levels of vehicle dynamic control and safety. Plus, we can make the front and rear crash zones larger and more protective. And in addition, by altering the length of the side sills, we're able to change the size and shape of the vehicle to virtually anything we want. With VPA, we can easily create multiple drive configurations. For example, we can change the number of motors for a particular vehicle, giving one greater range, or another more acceleration and horsepower. Front-wheel drive, rear-wheel drive, or all-wheel drive. VPA provides us with so many powerful possibilities. And I'd like to give you a stronger sense of what this means to us. I'd like to invite our Head of Global Design, Richard Kim, to the stage. Now, Richard's had an amazing career in automotive industry. He's even more incredible because of his young age. He comes to Faraday Future from Audi and BMW, working at both their American and European design studios. And his most notable work is he was the lead designer for the BMW i3.
Thanks, Nick. So Nick was correct. VPA provides us with many powerful possibilities. It's a designer's dream. Imagine, on this architecture, you could design a luxury sedan, maybe a crossover, a compact car, an SUV, even a pickup truck. Virtually anything is possible. And if we take this power, and we can even go as far as something like this. Please meet Faraday Future's FF01 concept. So I prefer to think of the FF01 concept not so much as a concept car, but more of a car of concepts, an extreme testbed for the fundamental ideas we're working on for up-and-coming production vehicles. So the job of the design team is fairly simple. Be advocates for the customer, create simple and elegant products, work intelligently, and fight ugliness. This car of concepts came about while we were working late one night on our future production car. And Nick wandered in my office and noticed this sketch on my desk. And it was a high-performance electric dream car. And Nick said, you know, we could put that on our platform right now. So as you can see, we took that challenge to heart. Of course, ideas are easy, but executing them, that's the hard part. One of our core philosophies is to design the car from the inside out. After all, we spend a lot of the time in the car. And while autonomous driving is coming, we also want to make focus on how we spend our time in the car now and make sure it's refreshing and enjoyable. So, we put the user's needs first, and that begins with the interior. We started with an all-white interior, a pure and extremely clean aesthetic that wouldn't be practical in a traditional internal combustion race car. The seat design was inspired by NASA research on zero-gravity driving positions. So the driver is placed at a 45-degree angle, and it optimizes comfort and maximizes circulation. We've created a drive-by-wire asymmetric instrument panel built around the features the driver utilizes the most. This propeller-shaped instrument panel previews an important piece of forthcoming FF design DNA. Located in the spine of the headrest is our Halo safety system, which integrates a head and neck support connection, as well as an oxygen supply and water supply through a port of our prototype helmet that we also developed in-house. We're looking at connectivity and customization in a whole new way that goes far beyond automatic climate control or a seat that remembers your driving position. We're taking the innovative, intuitive movements of digital devices and applying them to the interior of the vehicle, incorporating swipes, pinches, and touches. Augmented reality is projected on the road as your digital co-pilot. So this vehicle re-educates itself continuously about your needs in real time. A smartphone is actually docked in the steering wheel, allowing the driver to access information, control secondary functions, view live images, track their position, all without having to learn a new control language. Now, let's take a look at the exterior. As with a digital device, the race car is covered in contrasting matte and gloss finishes, smooth and three-dimensional surfaces, and light and dark values that connect the exterior to the interior. It's an extreme tablet on wheels. Utilizing lightweight composites and materials, our design team was able to experiment with new driver-focused proportions. The VPA, combined with these materials, gave us the flexibility to push the seating position all the way forward, which gives us a perfect teardrop aerodynamic profile. So, FF design, our philosophy is to draw inspiration from technology companies and product design, as is true for powerful mobile devices that are integral to your modern life today. This car, it embodies a true, perfect user experience, and it's anchored atop our powerful technology, VPA. As you look through the vehicle, through these tunnels, you'll see a highly functional, yet extremely beautiful element we call aero tunnels. These aero tunnels channel air directly through the vehicle. This yields several performance benefits, like reducing drag, battery heat, and power consumption. These aero tunnels are something engineers and designers have wanted for decades. There's a main character line that runs through the vehicle. This is a crease that we are now calling the UFO line. That runs around the vehicle, and it's a subtle design cue that this car is not quite of this world. This UFO line will be a signature design element in all of our future products. Of course, we know everyone wants to see a race car in action, so let's take a look. I hope you'll agree that the FF01 concept is a serious statement and a showcase for what Faraday Future stands for. Inside and out, the design and user experience seen here is a preview of our DNA and our FF products to come. Thank you very much.
Thank you, Richard. So, you've seen and heard a number of things tonight. We've talked about what drives us, literally and figuratively, to change the way the world perceives mobility. We've also talked about how we're going to achieve these ambitious goals. Number one, we have an amazing, world-class team. Two, we have a transformative vision. Three, we have incredible alliances. And four, we're moving very fast. And tonight, we've also shown you the FF01 concept, an advanced vehicle that highlights some of our ideas in design, power, connectivity, and driver interaction. But now, as we close, I'd like to leave you with just one last thought. The way that we interact with each other today is so very different to what it was even 10 years ago. And at FF, we believe, with every bone in our body, that the world is ready for a new way of looking at mobility. You don't need to have a 100-year legacy in the automotive industry to define what the next generation of transportation needs to look and feel like. For example, 9 years ago, this very month, the iPhone was announced. And if you had a mobile phone in your pocket back in 2007, as I'm sure many of you will have done, it was probably a Motorola or a Palm or a Nokia or a BlackBerry. Not many of you have one of those in your pockets today, do you? Apple didn't just redefine the phone. It transformed the way that we communicate, organize, and enjoy our lives. And that is what we at Faraday and Future are looking to do. We're looking to the future, seeking opportunities and working to bring them to life, to help redefine the world of mobility. So, we invite all of you to come with us and to help us shape that future positively for the generations to come. So, ladies and gentlemen, before we close, I'd like to invite Richard and Ding back onto stage. So once again to everybody, on behalf of Faraday Future, FF and LETV, we'd like to thank you very much. Have a good evening.